Box-and-Whisker Plot shows the variability of a data set along a number line using the least value, the greatest value, and the quartiles of the data set. Quartiles divide the data set into 4 equal parts. The median, which is the second quartile denoted by Q2, divides the data into 2 halves. The median of the lower half of the first quartile is Q1, and the median of the upper half of the quartile is Q3. A box-and-whisker plot is drawn along a number line. Your minimum value goes on the far left, that's your least value. Your maximum value is on the far right, the greatest value. If you find the median, which is the middle number, that's quartile 2, which will end up being the inside your box. On the left-hand side of the box is the quartile 1. Quartile 1 is the median from the least value to quartile 2, or the median, the number in between or the middle, the least value, and the median. Quartile 3, which is the right side of the box-and-whisker plot. Quartile 3 is the median, the number halfway between the median and the greatest value, whichever number is in the middle of the data set given. Your whiskers are lines that you draw from your minimum and maximum that connect to the box, and the quartile 1, quartile 2, and quartile 3 are lines that go straight down to make the box. The 5 numbers that make up the box-and-whisker plot are called the 5-number summary of the data set. The 5 numbers are your least or minimum value, quartile 1, quartile 2, quartile 3, and your greatest value, or the maximum. There are 3 standard shapes of a box-and-whisker plot. The first shape is skewed left, the second is symmetric, and the third is skewed right. Skewed left has a left whisker, or the left side, that is longer than the right side, and most of the data on the right side of the plot. A symmetric box-and-whisker, the whiskers are about the same length, the left side is about the same length as the right side, and the median is in the middle of the plot. Quartile 2 of the line separates about half the data on the left and about half the data on the right. The final box-and-whisker is skewed right. Skewed right means the right side whisker is longer than the left side. And for skewed right, most of the data are on the left side of the plot. When interpreting a box-and-whisker plot, the left whisker, which is the minimum value to quartile 1, should contain 1/4 of the data that is given. The box from the box-and-whisker plot, from quartile 1 to quartile 2, should contain half of the data that is given. And the right side of the box-and-whisker plot, the right whisker, should contain 1/4 of the data that is given. Another measure of variation is also known as the interquartile range, or IQR. The IQR, or interquartile range, is the difference of quartile 3 and quartile 1. It represents the range of the middle half of the data. For IQR interquartile range, Q3 minus Q1 will tell you how wide the box is, which is the same as the interquartile range, or IQR. Title of next section is Box-and-Whisker Plot. Using the following data, we can use these numbers to construct a box-and-whisker plot. Before you make a box-and-whisker plot, you want to make sure your data is ordered from least to greatest. So we'll have our minimum value, our maximum value, and then we can find our quartile 1, quartile 2, and quartile 3. Looking for the smallest number first would be number 16. After 16, number 17, and then 18. If it helps as you rewrite your data, you can cross off the numbers 16, 17, and 18, and continue to put the numbers in order. The next number would be 20, followed by 21, 22, 23, and 25. Once the numbers are in order, we now have our smallest number, our minimum value, and our maximum value. We do want to find quartile 2, which will be the middle of the box we'll make, and then we'll find quartile 1, which will be on the left side middle, and quartile 3, which will be the right side middle. Looking at these numbers, there is 8 numbers. If we have 4 numbers on the left and 4 numbers on the right, the middle of the entire data set would be in between these numbers, 20 and 21. If there is no number in the middle, we'll take halfway between 20 and 21, which would be 20.5. 20.5 will be our quartile 2, also known as our median. Once we have our quartile 2, we can find our quartile 1, which is the middle of the left-hand side. The left-hand side has 4 numbers. So again, if we divide the 4 numbers in half, 2 numbers on the left and 2 numbers on the right, this middle number would be between 17 and 18, or 17.5 would be quartile 1. If we repeat for the right-hand side, which again also has 4 numbers, 2 numbers on the left-hand side, 2 numbers on the right-hand side, so between 20 and 23 would be 22.5, and that would be quartile 3. We have our least value, our maximum value, and our 3 quartiles. So now we can draw the box and whisker plot. Drawing a number line first. We do need the smallest value to be 16 and the greatest number to be 25. So if we start at 16 and count up to 25, that will make sure our box and whisker plot will fit on the graph. Graphing our points, our minimum value again is 16, is represented by a single data point. Our maximum or greatest value 25 is represented by a single data point. Quartile 1, 2, and 3 are represented by vertical lines, and then we can connect those to make the box. For 17.5, we can count up to 16 and 17 and 18. Between 17 and 18 is where quartile 1 would be, and we can draw a vertical line. For 20.5, if we count up to 20, and 21 would be after that, 20.5 would be right in the middle, and that would be our quartile 2, also known as the median value. And quartile 3, which is 22.5, would be between the numbers 22 and 23. Once we have the least value, the greatest value, and our 3 quartiles, we can connect the quartiles to make a box. And we can connect our least values and greatest value to make the whiskers. And that would be a box and whisker plot for the data given, showing us our minimum value, our greatest value, and our 3 quartiles. Keep in mind 25% of the data is on the left, 25% of the data is on the right, and 50% of the data is inside the box.